Hi, it's Joshmi. In this session, we are going to discuss about the first session of Intel family or the fundamentals of the microprocessor, such as what is a microprocessor and what is how is addressing done inside the microprocessor, or overally it would be like how is the segmentation is done inside the microprocessor. I made a flowchart over here, also some notes for myself to remember what I'm going to discuss. Also, I'm going to make the notes visual inside the quick tips. The environment that I'm using right now is called Figma. Okay, as you can see just up here. You can just try it out. It's such a great app. I just found it out right now. Until now, I used to use Obsidian, but this one is much better. All right, let's go. Let's dive into what are microprocessors. Look, we have many type of microprocessors, but the first ones are made by Intel and they are called the 86 family, and the first one is called, if I'm not wrong, 8086 and 8088. I'm gonna just make it super visual right now. Here we go. Yeah, oh, it's a second generation. Here we go. Yeah, 8086 and 8088. These are the first microprocessors which were made by Intel. There are some topics, very important topics, such as real mode and protected mode inside these processors, and which one of them use the real mode and which one of them use the protected mode. And right now you would be like, what are these topics that you are talking about? What is real mode? Don't worry, we are going to dive into it inside the addressing or segmentation section. Alright, so let's just get started. And so what is a microprocessor? A microprocessor is something which sends order, like read and writes. You would just ask right now by yourself that what order to what. There are many peripherals inside a motherboard, such as memory, the graphic card, or there are some small peripherals such as PPI, DMA. There are some protocols such as UART, also called 16, if I'm not wrong, 1655. I exactly don't remember, but it's for sending and receiving data or instruction. So the base or the overall meaning of a microprocessor is a command, is a like command sector. It just sends and receives. And there are some mechanism for this thing, and I just wrote it over here. There are some move. The language of this mechanism is assembly. It's move, out, int, also called interrupt, and hold. And we are going to just discuss what each one of these mean and how they work by just visual examples. I'm just solving questions. So, why do we need addressing? What is addressing, or better to say? Look, inside the microprocessor, we gonna need to make connection with other peripherals, such as memory, which is the most important one. Inside the memory is our data, the data that we have saved. So how can we just receive this data? There must be some protocols or some mechanism, right? The mechanism works like this. Each data or code, also we call the instruction, has a base address, and this base address is the location of that data inside the memory. And whenever we are inside the microprocessor and we need some data to be read inside the monitor or wherever we want to just look at those data, we have to send the order to the memory into its base address and pick that data and come back. So there would be like a bus interface between these ones. Let me just make it much more visual. So imagine, okay, this is the node. This is the microprocessor. All right, I just make it like this, like microprocessor. And this is the memory. This memory has many segments. We call these segments like data segments, such as data segments or code segments, stack segments, and so on. When it comes to data segment, it's where the data is stored inside the memory. And this data in here has a base address. And depend on the base address that this memory contains, we're gonna just make it connection, like a bus connection through the microprocessor and the base address. Let's call this one the bus interconnect. This is like so easy. You would be like the microprocessor just gets the data. No, look, this is for the very first microprocessor, like the 8088 and 8086 microprocessors, which work in the real mode. Let me just make it. They work in the real mode. The real mode is so easy. Look, the memory has 16-bit. I mean the microprocessor 8086 is working inside the 60-bit, and definitely these base address are working in the same bit. But this bus interconnect in here is 20-bit. So for example, we have a data inside a specific address. Let's just define it based on a real example that I have already with myself. Like this one. Imagine my data is stored with a base address, such as the data segment. We are just considering the data. We just want to pick up data. This data is inside the like 5. Let's not just call it 5000 like hexadecimal value, and we just decided to pick another data. This is the address of this data, and yes, we just pick this one and send it through the bus, and also because it's 20-bit, we just add 10 to it and send it to the micro. But let's just imagine I don't want this specific data. I want to pick, for example, this is the base address 1, and there is another segment with another base address, like base address 2, and it is another data segment, and the data is here. And imagine I want another data. So how can I just pick up this one? Look, between this one and this one there is an offset. We call it just the offset. How this offset is determined? It's determined through the program counter. Also, I just defined it here. Yes, the program counter. Program counter is not a segment, definitely. Program counter is a register that it counts, depends on the data that we want. For example, your register is living inside the 5200. I mean your segment living inside the 5200 segment, and you are in 500. So how can you just move from 500 to 5200? there must be some counter over here. That's the job of this register. And if you want to just dive deeper into it, I made a much more visual explanation. Like the program counter is inside the microprocessor. Yes, it's inside it. And meanwhile, the micro and the memory are two separated peripherals. We know that. We just made it visual. We just drew that. And we make connections between them through the bus interface to obtain data or instruction. This DS means data segment. This data segment and CS, which is code segment, are inside the memory, and the memory which contains the segments, not the micro. Micro just read and write. So we just have to make a count. And for example, now we just made a count, and it was like two. Oh, sorry, made a point. Why I did that, I don't know. Imagine it's 200 hexadecimal address away from the first data segment. So now this base address is definitely the sum of these two. Actually, it is not the sum of these two. The bus interface is 20 bit, and the base address is 16 bit, as we said. So we have to, the data segment address, not the base address. Let me just remove this one. The data segment, data segment is 16 bit. Because the micro that we are working, 8086, is 16 bit. So all the segments or instructions, or even the transfer, no, not the transfer. Definitely, I made a mistake here. The transfer is 20 bit. What I just wrote here is a hint. Even though but. I just meant even though the bus is 16 bit. The micro is 16 bit, but our system works, our bus works in 20 bit. Don't mistake in these two. So the microprocessor works, that would be the data segment would just get 1 0 over here. Then the sum of these two segment and offset, yes, this is the offset, we just discussed about it over here, would be 5020H. This is the base address of this specific segment, which it goes to the bus, then it just gets read by the microprocessor. Alright. When we are in real mode, that's how data is read. Alright, but in protected mode, it's whole another story. We have something, a topic or a concept, which is involved with two address. Why two address? Not one address is enough. No, there is another address going to the descriptor table. This descriptor table would make the system a little bit safer, as I read about it. So we're gonna just use it. So let's just go back to our topic and go to the first page. Alright. So we just realized what is a microprocessor, and we discussed half of the way of what is addressing. Oh, segmentation. Look, the segmentation is where the descriptor table comes, and it just shows itself as a real player. Alright, is there anything very important to mention over here? Yes, we just discussed this one. Maybe I can make a comment. Here, cool. Yeah, we just discussed this one. Oh, it's so big. Alright, can I make it smaller? Yeah. Let's go to the next topic. Protected mode. Maybe better I just explain about the segmentation than the protected mode, because it's a very important topic. Alright. We just discussed about it. Now we are going to discuss about the next topic, which is protected mode. Let's remove all this. Sorry if my English is not pretty perfect. I'm not English. Right, let's just make a text over here, and this is working working on remote. Here we go. Let's just move it over here. Not a very good position, and make the size a little bit larger. Oh, that's so large. Okay, let's just make it here. Yeah. We could just make the same, and here to make it working on protected mode. Perfect. It's the first time I'm working with this app, and it's literally perfect. All right. So how is the protected mode is working? The protected mode contains exactly the same microprocessor. You have the microprocessor and the memory. No problem with that. The memory, both are peripherals, just separated. Am I saying it right? Peripheral, yeah, that's cool. Then there is another one which is called the descriptor table. Descriptor table, here we go. So what's the story about this descriptor table? What is going on? Why don't we just read it normally like the first microprocessors? This is working with the latest microprocessors such as 8286, 8386, 8400 and 8586, which is they just changed the name and called it Pentium. We have and that's cool. There's some good data over here, like it's 32-bit working inside with a bus of 32-bit. That's cool. External bus 64. Wow, 64 is maximum. I just want you to focus on the bits, and look, we started with 16 bits. 8088 is even 8-bit. We started with 8 bits to 64, which is the latest microprocessors. But we're gonna just discuss until the 32-bit Pentium microprocessors. Now we are discussing, like, let's just say the 80, 386, same 486, and Pentium. These systems, actually, Pentium works super scalar. It's just not. It's just a little bit different. Let's just focus on protected mode, which works in the second, fourth, and also the second generation. Third. Yeah. These are the 86 family. Actually, x86 family. So, what's the story about the descriptor tables? Alright, look, the microprocessor contains something which is called actually the microprocessor, the descriptor table contains something which is called the base address. So instead of we just go forward to here to pick up the base address and just check the size, access right, or everything just goes inside here. And just remove it. The base address is here. For example, base address 1. Maybe it's the descriptor table 1. So we are just talking about the base address 1. So we had these segments such as data segment, code segment. There is something which is called the segment selector, segment select. And we go to the descriptor table, pick up the wanted segment. It depends that you want the code segment, data segment, a stack segment, or whatever. You just have to go to this part. All of these I'm going to just discuss about it a little bit later, that all of these just happen inside the execution unit, and the execution unit is part of the microprocessor. So the segment selector picks the wanted base address, and after picking the wanted base address, it just sums with the offset. After being summed with the offset, it gives the wanted address, which the physical address. Now you would be like, what is a physical address? Look, the last address after the last address which is read, which is actually received by the microprocessor is called physical address. So we would just get the physical address. Now you would be like, what about the memory? Alright, we get the offset from the memory, we get the base address from the descriptor table, obviously, so we pick up the offset. And yeah, memory is not. Then after picking all of them, then we just got the physical address of the data, and it just makes the connection or bus connection with the microprocessor to send the data bus. Also, this bus does not, this time in protected mode, we do not add like a 0 to make it 20 bits. The overall physical address that we will get in the end is 20 bits. Alright, this is 20 bits. By the way, there are some topics such as linear address and other things that, for example, if we have paging, then we won't get the a straight physical address after summing up with the offset. If we would just get the linear address, which is summing with the paging, then that would give us the physical address. But right now we have no paging, so we just make it super easy and continue on. Alright, that's all. Why I did that. Alright, that's it. Let's just solve some questions like this one. The question for protected mode is a little bit harder, and you have to give all your focus to me. Let's just dive deep a little more into this segment selector and the descriptor table. These two ones, I guess, for the first time it was super hard for me to understand. Oh, that's cool. To understand the segment selector and descriptor table and why they do exist. I even didn't know that protected mode and real mode are two different things, but after time realized there are two generation and two different mechanism of addressing. These are all addressing. Alright, so let's just solve a question over here. Let's just make it bigger. Let's make it bigger. Here we go down over here. Alright. Little bit much bigger. Alright. I have a question here. Let's not make a question by ourselves, because definitely we are going to make mistakes. Alright. Here we are. The segmentation. Oh, segmentation is super important. Before going to solve a question, let's just explain in here. Maybe I take a screenshot and explain over there. How this is done. How is it done? Let's just dive it. Alright. We need a pen. Alright. Okay, this is the segment selector contains the logical address. Logical address is the DS, CS, and so on. And it goes to the segment descriptor, which gives us the base address. Actually, no. Oh yes, why is it no? Yeah, it gives us the base address. Then the offset is summed up with it, and we would have the linear address. Linear address is the same physical address when we have no paging. Alright, when we have no paging, it's the same. That's easy. I just made it visual over here, but this visualization is much better. Let's solve a question. Make it a little bit bigger over here. A question. Another cool thing. Oh, inside the descriptor table, this is what we have inside it. Okay, I going to mention again, we have the size access right and the base address, and also some words that we are not going to discuss over here. These are the main parts that we are going to need. Base address, which is in the byte 7, 4, 3 and 2. Limit is size, so if it's written limit, don't wonder what it is. Don't worry, it's just the same size. Make it black, its size. So we are going to solve a question based on the table that we have over here, and this is the segment selector. There are some other parts with the segment selector that we are not going to need so much. Alright, descriptor table, and yeah, that's cool. Here the question. There are some tables that we need. Let's just make an overall screenshot of this. Here we go. Here. All right. We have the data segment. All right. We are gonna just pick up the data from the memory. So we want the data. That's cool. Also, we have a register. All right. Maybe it's our yeah, it's not mentioning it, so most probably it's our offset. Cool. So as we just saw inside the segmentation, through this segment we pick up the base address. So which one in here is a segment? This one, data segment. So it's 10. Just make it over here. So I have to make the screenshot of this to make it much more visual to explain. I have it in my papers, but you have to see as well. I just didn't want to pick it up, but I made a mistake. I had to pick it up. Alright. Look, the data segment is 10. So just pick this one and here. So it would be like 0, 0, 10. I mean 0, 0 is 13 bit. Oh yeah, I just don't want to make any mistakes. Is 13 bit. I'm just talking about here. So it would be the first 13 bit here, 10. Then these ones also it's 1 bit and it's 2 bit. That would be total of 15 bits. Actually, why it's 2 bit, 1 bit, 15 bits? It must be 16 bit. I'm making some mistakes because you know it's the 286 is second generation, and second generation is 16 bit. So it must be 16, alright. Then we got these ones as first bit 0, the other 2 bits in here 0 as well. But we don't need these ones, as I talked about it, we don't need them. So it would be 0, 0, 0, 1, 10, which is 2. Alright. In here we're gonna, as saw inside the segmentation table, we're gonna just pick up the descriptor table. So this is 0, this is 1, this is 2. We just picked up the second one. Alright. Let's go into the descriptor table. Also the schematic of the descriptor table is seen as above here, and it's bit 7, so we're gonna pick this one, and it's bit 4, then this one, and 3 and 2, this one and this one. Alright, we don't need these ones. This is the base address that we want. So the output base address would be like 0, 0, 1, 0, 1, 1, 4. Yeah. I guess, yeah. Oh, wait, another 0, yeah. 0, 4, H, hexadecimal. This is the base address, and also the offset is 2, so we just sum it with a 2. That would be 001000006. So we come to the memory and check which address is this one. Alright, that would be, I made one, no, that's fine. Alright, this one, no, it's not here, no, here we go. This is the address that we have found. So this is the address that we need, 30. So the physical address is 30H. Alright. That's it. We just found the physical address, just as we found the physical address inside the real mode. This is the physical address. The last address that goes to the microprocessor. Alright. So we talked about addressing, and I heavily apologize if I explained not very well. There are some other mechanisms inside microprocessor that we haven't talked about, but it's getting very long video. I don't want it to be long. And if there is any question, just ask in the comment section. And if I said anything wrong, just please fix me, because definitely I have mistakes and I really need your helps. So if there is anything, just share with me. Thank you for your support.